Hi, this is Eric from Astro. We've received questions and comments about the quality of the 3D printed instrument and its parts, so I'm addressing them in this video. First, it's important to evaluate the TiltAdjuster as a complete product. The 3D printed instrument itself, the adapter that fits precisely where it is mounted, and the software application that records, calculates, and provides a real-time view for adjusting tilt. The reason the instrument is 3D printed instead of CNC machined is mainly cost. CNC machining would make the product significantly more expensive. We haven't produced a CNC version for comparison, but we have performed extensive testing and verification on the 3D printed units to ensure quality. Many customers have used the instrument with excellent results, which also demonstrates that minor production variations do not affect performance. We have continued improving the design, and we can say that the Generation 2 instrument and adapters have very small production variances and deliver consistent results. In this video, I will demonstrate this by testing several instruments with different adapters. A short background. Before I start the test, I want to show the construction of the adapters that are now delivered as Generation 2. The first generation was already quite stable and produced excellent results. The main source of instability came from how the adapter fit onto the extension where the instrument is mounted. The Velcro solution worked well for most extenders as long as the instrument was used carefully and correctly. The real challenge appeared with the M54 version, because the M54 standard does not define the outer diameter of the adapter. This means different manufacturers produce slightly different sizes, and even units from the same manufacturer can vary. To handle all these variations, we needed a more flexible and consistent solution. That is why we designed a new version, which you can see here. The new design is now used on all adapters. Its main advantage is that it provides flexibility to accommodate variations in adapter diameters while still centering perfectly on the extender. The adapter has thin slats that allow it to flex just enough to grip securely while maintaining stability during rotation. This is essential for the TiltAdjuster concept, where the instrument must rotate freely without introducing tilt or misalignment. As you can see on the side, a cable clamp is included to prevent any drag on the cable at the top. This is important because cable tension can tilt the instrument and negatively affect the measurement or adjustment. So let's take a look at the instrument. Some people have commented that the way the instrument connects to the adapter looks a bit unusual. In reality, this is an excellent mechanical solution, and it benefits you as a customer because it allows us to support many different adapter sizes without requiring you to buy an instrument that fits each one individually. Connecting the instrument and adapter in this way can cause a small shift in where the laser hits the sensor, and therefore where the reflection is captured by the instrument's camera. As a result, the position of the plotted circle may appear slightly different each time the same adapter is mounted on the instrument. This does not affect the measured or calculated results. The mathematics compensates for these small variations. The historical results are shown here from the same instrument, but using 4 different adapters. When you visually compare the circles, you'll see only very small differences, and in all cases except one, where I was a bit clumsy, the variations are negligible. When comparing the size of the circles, their position is not important. For that reason, all circles are drawn with the same origin, but with their own measured size. This makes the comparison much easier and much more meaningful. The same applies when looking at the values for tilt angle and sensor diagonal tilt. The variation in angle across the 4 adapters is within 0.006 degrees, which in my opinion is strong evidence of both accuracy and overall quality in this context. So here is my setup for the test. All the adapters used in this demonstration are brand new and have never been tested before. As you can see, there are 5 M54 adapters in total, and one of them is already mounted on the TiltAdjuster instrument. I won't bore you by showing every single test. Instead, I'll demonstrate one full wizard round so you can see exactly how I use the instrument. This will be shown together with the real-time view, which displays the rotation and sampling as it happens. As proof of the results, I will present the measurement outcome using the registered historical data. The adapter has an external alignment slot that I use to orient the instrument toward the camera's adjustment screw. That is always the first step. After that, I start the wizard, keep my hands off the instrument, and press auto. The application acquires 20 frames, which are processed and filtered to compute an averaged measurement value. Next, I rotate the instrument. Notice that I always hold the adapter, not the instrument itself. I apply a firm downward pressure so the rotation is as smooth and stable as possible. Do not hold the instrument at the top. Doing so can introduce tilt. Repeat this process for as many screw positions as you have defined in the selected profile. When all positions are completed, the application presents the final result. And here are the results for test 2, where both instruments were tested using all 5 adapters. A bit of simple math gives the variation values shown in the text on screen. To evaluate the quality of these results, I fed the data into an AI analysis model, and here is the verdict. I'll let you read it yourself. So, to the conclusion, it's of course up to you to judge, but both I and the AI analysis agree that the 3D printed TiltAdjuster with its optics, camera, and software provides a good, reliable, and repeatable way to eliminate tilt in an astro imaging setup right at your desk. That wraps up this video. I hope you enjoyed it, and please feel free to leave comments, both positive and negative. Feedback is one of the ways we continue to learn and improve.